Hello everybody and welcome back to another Houdini tutorial. My name is Kate and today we are going to be building this guy. We are continuing our process that we started in a previous tutorial where we built the RBDs that you see crashing down here and the particles, but this time we are also adding some smoke and other particle effects to complete this design. This entire effect will be done over a period of 3 different tutorials, so this will be part 2, and we'll be covering the secondary kind of smoke effect when the character falls, and also kind of the pieces that hit the ground. So let's kind of get started on that, and I'll walk you through it. So as you might remember, in our previous tutorial, we set up our RBDs. So our main RBD sim, we set that up. We also set up some particles that when this character falls, he emits these particles all over the ground. And we also set up some bottom debris. So these emit from RBDs that go like this. But now we're going to add this smoke that is emitted from the character when he starts to fall. So jumping up here, let's talk about how we're going to set up our smoke emitter. So I've dropped down an object merge, and in this object merge is an into this object guided sim 1. So playing this back, you can see that our character falls and we are basically grabbing this null over here. Then we are adding a delete stop. What we're doing is deleting the group inside, operation delete non-selected, and that should grab you the inside groups of your emitter. Then we are going to go to pyro source, and what this is going to do is going to surface scatter over primitives, and we are going to create this emitter for our pyro object. So back up to after scattering our points, what we want to do is create our velocity. So when you create your pyro source, and you can create this pyro source and the rasterize attribute in the solver by doing this, where you can go billowy, configure smoke, and you can grab the nodes you need and then use them in your pyro sim. So that's an easy way to grab these 3 nodes. So, taking a look at our velocity that we need to set up, what we need to do is we need to go to attributes, click plus, scroll down, and then go to velocity, and then it will set up that velocity value for you. Then we go to rasterize attributes. So we want to rasterize the velocity and the density. We want to do voxel size of 0.06, and then just play with a minimum filter size and velocity blur. Then we can go down to our billowy smoke and kind of get started creating the smoke. So you can see that I have a collision object over here. Over here I'm bringing in our ground plane. And I'm grabbing our ground plane that we set up in a previous tutorial where it's at ground plane object, import ground plane. So using that on our billowy smoke. So you can see here that I've offset it to frame 30, and that's simply because if we look at our character, he doesn't really quite start really collapsing until frame 30. Then we go to setup. I've changed the voxel size to 0.02, gone to bound, not changed anything, gone to sourcing, and limited the frame range between 30 and 75. So that's how long the poof is going to last for. I've also turned off cycle length. Then I have volume 1, which is our density, so it's 0.6. Volume 2, temperature, played with the acceleration strength. And volume 3, vel and 0.959. If your vel doesn't exist, you can add it by going to number of sources plus and going to add, and then adding V in here and vel in there. Then we go to our field. So in our fields, we have our dissipation. We're going to be using dissipation and animating dissipation over time. So I'm going to switch this over to manual, and I'm going to go to frame 76. And here my dissipation is at 0.08. And then around frame 117, I have it at 1. So it's going to completely disappear after this point. Then I've remapped the control field, and that's pretty much it. Then I've gone to shape, And I've turned off buoyancy and wind. I've cranked up my disturbance values to 90, and I've played with the base block size and the max octaves. Scrolling down to turbulence, I've played with the turbulence size, swirl size, roughness, pulse length, and octaves. And I've added a little bit of viscosity. Alright, so as you can see here, we have two things. So we have gas disturbance, which is scale, and swirl size are adjusted, along with turbulence. And gas disturb, which we have our strength at 20, and we've played with our base block size. Then I've cached this out, and then I've transformed it so it's matching up with the character's feet. So if I play this back, I found out my ground plane was just a little bit offsetted for my character, so I wanted to transform this down just a little bit, because if I go to my cache, it looks a little bit offset, so I just lowered it back into place. Then I added my null, and that's how I created the smoke for our character. Now I'm going to turn these off, because now we don't really need to take a look at that. We need to take a look at our character over here. So now we're going to take a second to look at these parts of the simulation. So these things all highlighted here. So let's dive inside. There are three main objects to this simulation. One is the points, and one is the billowy smoke. There's also some extra smoke particle poofs that we have exported as well. So let's jump up here, and I'm going to turn these off. So for our guided sim, we have outsim 1, and so we are grabbing our character. We're using him as our emitter. So we're going to go to converts, and we can play it back like this. And then we are going to choose a point to basically create the emitter for our explosion. Now you can use this particular thing as the emitter, but I like emitting from my own kind of solid, to be honest. So basically what we've done is we've isolated the foot or the back half of Craig here. So this little guy in the back. So if I ghost him, you can kind of see where the emitter is right there. Then I put down extract centroid. So this is going to extract a centroid from the heel of the object. Then on the heel of the object, I've copied 2 points, a platonic solid. So this goes in there and this goes in there. So isohedron radius 0.15. Then you can see there's 2 inputs going into a popnet here. So let's talk about them. The first one is a group of 3 points that we are basically spinning around like this. So 3 points, and global seed is $F sign. Then we go to orient along curve. And what orient along curve does is basically it recomputes your normals. So if we look at this, we look at our normals over here. These are kind of our normals. And we look at them now, they're different. So that's cool. Taking a look at our particles, we have some stuff happening. I've given this a start frame of 13. I'm going to turn this off because I don't need it. So I've decided to start the particles at frame 13. Diving inside. I'm just going to hit L on my keyboard so we can keep this organized. And then we can go to source first input. Then we go to source. We're using the first context geometry. We're going to the birth tab. So this $FF20. So basically after frame 20, this will stop emitting particles. Then we go to our impulse count, 5,000, constant activation, 0, constant birth rate, 23,000. Then seed, life expectancy, and life variance are played with as well. Now we have our pop vop. So diving inside, we are going to be playing with the velocity. So now we're saying, okay, let's base the velocity off the normal and also multiply it by a constant or something. So we have plugged the normals into a multiply and fed into the velocity. Then we have added an input here. Now you can see the input number here, and we've multiplied the normals by 7. Then at pop force, we have amplitude, 500 and swirl size 1.6. Pop bop. Now this is where we got our color and also play with our velocities a little bit more. So diving inside, we have our ramp going into our age, which is creating color values and being fed into our color output. So that's pretty cool. So age into ramp. Over here we have an add node, which is adding our velocity plus our normal together, vector to float, and float to vector. There we go. Then we have our pop drag. So I've added an air resistance of 10. Then I've added some color. Well, not yet, at least. We're getting there. I've decided to play with the alpha of the particles. So I've turned off update color, but I've gone to the alpha tab and I've decided to ramp the alpha by the life expectancy of the particles. For the pop solver, I've turned on mid substeps 3, max substeps 4, pop object, haven't changed much here. And for our collision objects, these things, instead of just creating them manually, which you can do, what I like to do, just to make sure all of my collision objects work the same way, is I zoom out like this, I go in here, and I go into a previous PopNet that I've already created collision objects for, and I just grab these, I go copy, here, and then paste. And boom, there are your collision objects. Then delete is deleting all of our collision objects in the basically the PopNet, but we have our group, stream source input, and operation delete non-selected, entity points. Then we've cached everything out. So now we have something like this. Now we have an attribute randomize, which is p-scale, min value, max value. And then we have our null, which is our out points, like that. So our points should just go outwards like this. I'm just going to save this. And then we have our trail node. So our trail node, I've decided I wanted to just trail these particles a little bit more so they have a trail buddy. And this is going to be feeding into our pyro. So once again, you can create your pyro nets by going to billowy, configure smoke, like this. And you grab what you need. Saves a lot of time that way. Who knows? So after your pyro source, you're going to want to basically switch it over to points, keep input, particle separation 0.03. And then you go to density, temperature, velocity, and you can create your velocity once again by clicking the arrow here and going to velocity. Then we go to our rasterize attributes. So you should have your emitter or something that looks like this at this point. And we want to rasterize velocity and density, and then go to voxel size, particle size, minimum filter size. And you can even add motion blur if you want. Then I've cached out my emitter, so I can have more control over it and save on sim time. And then I've added a null here. Now we can add our billowy smoke. So once again, we see we have a collision object. So in this collision object, I am once again grabbing our ground plane. So I'm bringing it into there and feeding it into our billowy solver. So going up, we have our setup. So we have our voxel size, like that. And then we have our bounds, which we haven't changed. Sourcing, which is sourcing our densities, 1.6. Temperature 1 point there. And playing with our velocity. Then we have our fields. We are playing with the dissipations, 0.2. And remapping the control field. Then I've turned off buoyancy and winds, and we have our disturbance levels at 8.9 base black size, and we are playing with our turbulence once again. Going down here, we're playing with our viscosity once again. Then we go to our look dev. We can basically make this as dense as we want. I've have it on 5, and that's pretty much it. Then I've cached out my smoke, so playing it back, we should have smoke like this. And then I've added a null. Then I'm going to go back up here to my first emitter. So as you remember, we brought in our sim like this. So I've created another null over here called pieces. And pieces is going to go into our nether particle simulation. So we have our scatter, which is the first total count 45, and we haven't changed anything else. Then we've added some velocity noise to our character. So I don't know if you remember, but our character has velocity on it. And so now that these points have the velocity of the object, I just want to trail the velocities just a little bit more to give it more variation like this. So that I've added a point velocity and I've turned on curl noise like this, and I've left this tab alone. So everything looks like that. So now let's go down to a popnet. So I've created a popnet and you can kind of see the effect already happening. So if you play it back, it kind of looks like this. So we have substeps of 2, start frame 32, and then we can start to discuss this. So let's go to our source first input. So source first input, let's go to the source, we're using points. We're using the first context geometry. Birth, impulse activation is $F before frame 34. So after frame 34, this shouldn't emit anymore. We have an impulse count of 3. Constant burst rate is 95,000. Now, birth rate and life expectancy are fine. So now we can go to pop winds and we can go to amplitude and we can play with our turbulence settings. Then we're adding even more noise into this sim. And for pop color, we're going to do the color tab, we're turning off color, and we're just playing with the alpha channels. For the pop solver, I've done nothing, and for the pop object, I've done nothing as well. Once again, I've copy and pasted my collision objects into here. So just copy and paste, like that. Then I have my gravity node. And so now we have gravity in our sim. So once again, we're going to put down a delete, and we're going to delete stream source first input, delete non-selected endpoints. Then we're going to cache this out, and we're going to have an explosion of particles kind of like this. Poof. Now you might notice that these particles are kind of sticking around before the actual sim starts. So I don't want that to happen, so I've added a switch. And I've animated this switch to switch over from this null to the input like that. Then I've added some color. So I'm scaling this color over points, color type, random attribute, and hit time. So I'm playing with this color scheme like this. So over time the colors kind of fade into this white, yellow, blue tone. Then I play with my P scale like this, and then I've added an out points poof. And so all together, you should, if I turn off these 3, and we play this back, you should now have the basics of the second half of this simulation. And I hope you enjoyed this Houdini tutorial, and I'll see you in part 3.